Okay, you guys, we are starting a new section, and you say, wait a minute, we're starting a new section. It's almost the end. This is the last assignment. And it's like, yeah, I wish we could do more with trigonometry. We're just gonna get a little into it, but at least it's something. It's better than nothing. So here we go, trigonometry. Here's how it goes. Okay, okay. I'm going to set this up and then show you where all these trig functions come from. Okay, first of all, I'm starting off with an x and y axis, right here. And I'm picking a point in the plane, just x, y. X is the x coordinate, y is the y coordinate, just a generic point, okay? Now, you can always create an angle that has the x-axis as its initial side, the positive x-axis right here, and this terminal side, this is called the initial side, the other side of the angle is called the terminal side, and make it go through this. So I made it so that this point is a point on the terminal side of the angle, okay? The angle is this angle right here, which we happen to call theta. You could call it whatever. It's like an x. Theta is like an x for angles. It's an unknown angle, theta. Okay, so here's what you do. We're going to try to find the different trig functions of the angle theta. Okay, so here's what you do. You can drop a perpendicular from your point down to the x-axis. If you do that, drop from your point down to the x-axis, you get a right triangle all the time. And in fact, I'll draw this right triangle in red. That right triangle right there with theta being one of its angles. Now, if you use this point xy, then look, this is the x distance, this is the y distance. This is the point xy. You go on x this way, y this way. So it turns out that this is x and this is y all the time. If you're using the point here, this side or this leg of the right triangle is x, this is y. And they called this the hypotenuse, they call r. It stands for radius because there is a circle this is associated with, a circle that has that as the radius, centered at 0, 0. We're not going to talk anything about that circle right now, but I'm just letting you know that so that you know why that's called r, not h for hypotenuse, but they call it r because it's the radius of the circle. But it is the hypotenuse of the triangle. That's where it comes from. Okay, now, so you can do that. When you drop a perpendicular to the x-axis, you create a right triangle. This side's x, this side's y. We call this side r, the hypotenuse. Okay. Now, given those distances, x and y and r, you can come up with 6 different ratios of the sides of the triangle. That's what trig functions are. We're going to talk about sine, cosine, tangent. All those are ratios of sides of a triangle. It's one side over the other. It's like y over r, or r over y, or x over r. It's one side over the other side. So here's how it goes. The sine is always opposite over hypotenuse, right? So it's going to be opposite over hypotenuse, which is y over r. Because notice, y is the side that's opposite the angle. X would be the adjacent side. So opposite over hypotenuse would be y over r. That's going to be sine. Sine is always y over r. Okay, cosine is adjacent over hypotenuse. Adjacent over hypotenuse. And that's going to be x over r. And then tangent is y over x. So that's going to be opposite over adjacent is going to be the tangent, which is y over x. Now those are the 3 functions that are used way more often than their reciprocals. These are the reciprocal functions of these guys. Cosecant, secant, and cotangent are the reciprocal functions of sine, cosine, and tangent. Okay, that's just how it is. That's what they're called. We use sine, cosine, and tangent a lot more than we use these reciprocal functions, but it is good to know the reciprocal functions as well. So we're going to go through those, but that's the main thing. Hey, I know a good way to remember it. There's a thing that goes like this, like say you are marching around a campfire and you burn your toe, okay? You step in the fire on accident and you burn your toe, but then you remember there's a river down about a couple hundred yards away from you. So you run down to the river and you say, hey, I know what I can do. I can Sokatoa, right? Sokatoa. So it turns out sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So remember, you ever are marching around a campfire, you burn your toe, don't forget trigonometry. It sounds like this. But that's not what it means. It's really this. It's a different language, okay? So just understand that's how it works. But it does help you remember that, okay? Now, here's the thing. I told you the cosecant, secant, and cotangent are reciprocal functions. What does reciprocal mean? Just flip the things upside down. Now, okay, so it goes sine, cosine, tangent, then secant, cosecant, cotangent, okay? So it makes sense. You say, okay, what makes sense? Sine, cosine, okay, if I got sine and cosine and I got secant and cosecant, what would make sense to be reciprocals of the other thing, right? Wouldn't it make sense for secant to be the reciprocal of sine and cosecant be the reciprocal of cosine, right? That seems to make sense, right? So what do you have to do? You have to ask yourself what makes sense and then do the opposite, because that's not how it is, okay? It should be secant reciprocal of sine, cosecant reciprocal of cosine, but unfortunately they didn't consult me when they invented the terminology, and it turns out the reciprocal of sine is cosecant, the reciprocal of cosine is secant. Don't ask me why, that's it. I would have recommended differently, but they didn't ask me, okay? One good thing is the reciprocal of tangent is cotangent, like you would expect. But secant and cosecant are flipped around. So just remember that, okay? So, wait a minute. Sine, remember, cosecant is the reciprocal of sine. Well, sine is opposite over hypotenuse. Cosecant is hypotenuse over opposite, which would be r over y, right? The reciprocal of y over r. Secant is the reciprocal of cosine, which is going to be hypotenuse over adjacent, right? Which would be r over x. And cotangent is the reciprocal of tangent. Tangent's opposite over adjacent, so cotangent is adjacent over opposite, which is going to be x over y. So there we go so far. Okay. In fact, so far, that's it. That is the trig functions right there. That's what they are. That's the thing. They're all just ratios of sides of triangles. So we're going to find the 6 trig functions of different angles. We're going to start off pretty darn easy. I also have it written, I have it summarized nicely up there, if you can do that. And then I'm going to go to, I'm going to let you look at that for just a second. Let that sink in. It's the same thing I have written right here. Okay. So here's going to be the first type of problem we're going to do. Okay. Find the values of the 6 trig functions of the angle whose terminal side passes through the point 3, 4. Okay. This is a very simple and easy one. Okay, you're going to like this one. It's simple and easy and nice. They get worse than this, but this is the easiest kind. Probably the easiest one on the face of the earth, right here. Okay. Here's my x and y axis, okay? I'm going to use the point 3, 4. Now, this is the point 3, 4. So I'm going to drop my perpendicular to create my triangle right here. And look, the x is 3, the y is 4 right there. So far, so good. The question is, well, what is the hypotenuse? Well, it's not, well, it might be obvious to you if you know your Pythagorean triples, but it's not always obvious. You have to calculate it. To do this, we use the Pythagorean theorem. Leg squared plus leg squared is hypotenuse squared. Or they put it sometimes as x squared plus y squared equals r squared. That's it. Remember, this is r. So we're going to go x squared, 3 squared, plus 4 squared equals r squared. That's 9 plus 16 is r squared. 25 is r squared. So r is square root 25. You could say plus or minus square root 25, but the r is always positive. Right, so you don't have to worry about it. It always turns out to be positive, so you only have to take the positive square root. So r becomes 5. Okay, now from the point I got the x and the y, the 3 and the 4, I had to calculate the 5. You're going to have 2 points. You got to always calculate the hypotenuse. It's not given to you. You got the x and y given to you. The hypotenuse has to be calculated. Okay, now so that just tells me x is 3. Y is 4, R is 5, right? There's my 3 numbers. And now finding the trig functions is a piece of cake because you just go, okay, sine is gonna be y over r, which is gonna be 4/5. No way, yeah, 4/5. Oh my gosh, okay. Cosine is x over r, 3 over 5. No way, yeah, okay. Tangent is y over x, which is 4 over 3. Okay? Cosecant is reciprocal of sine, so it's r over y, which is going to be 5 over 4. 5/4. Secant is reciprocal of cosine, which is going to be r over x. Yeah, r over x, which is 5 over 3. And finally, cotangent is going to be x over y, which is 3 over 4, 3/4. And there's the 6 trig functions. It really is that easy. Oh my gosh, can you believe this? I can't. Okay, let's do one a little bit tougher. Let's see, it's the same thing except I'm just changing the point. It's not going to be 3, 4 anymore. It's going to be, in this case, 7, 2. So this point is going to become 7, 2 instead of 3, 4. So let's see how that works. Erase these guys. Okay, 7, 2. So here's my x and y axis. Okay, the point 7, 2 looks something like this. Okay, so this is the point 7, 2. I'm going to drop a perpendicular right there, create a triangle. Here's my triangle. This is my angle theta right here, okay? 7, 2, so look, 7 in the x direction, 2 in the y. I have to calculate the radius here, or the hypotenuse here. X squared plus y squared is r squared. So 7 squared plus 2 squared is r squared. 49 plus 4 is r squared. That's 53 is r squared. So r must be square root 53. Okay? Not a pretty number, but that's what it is. Sometimes it's not a pretty number. Sorry. So it's root 53. We just calculated it to be. So x is 7, y is 2, r is square root 53. Sometimes they're ugly like that. That's the way it is. Okay, so let's do these guys. So sine is y over r. So it's 2 over root 53. Well, guess what? Remember, you're not allowed to have square roots in the denominator. So to rationalize that denominator, we unfortunately have to multiply by root 53 over root 53. And the sad fact is, those dirty dogs think that is actually a pretty answer than 2 over root 53 because it's rationalized. Go figure. Not me. I think that's prettier, but they think that's prettier. That's the correct answer. Okay? Same idea here, because you're going to, x over r is going to be 7 over root 53. So same sort of deal. Oh my gosh, we don't want root 53 in the bottom, so we have to multiply by root 53 over root 53. We get 7 root 53 over 53. And unfortunately, That is considered the simplified answers. Sorry, I wish I had control over it, but I don't. Okay, how about this guy, y over x? Yes, good news finally, good news. Look, y over x is gonna be 2 over 7. 2 sevens, ooh, not so bad, okay? How about this guy? Wait a minute, it's gonna be r over y. Don't go 53 over 2 root 53. Go like this. R root 53 over y is 2. You say, oh my gosh, there's not a root in the denominator, so we can leave it like that, okay? This is gonna be root 53 over x, which is 7, so root 53 over 7, and then finally x over y is just gonna be 7 over 2, 7/2. So there you go. So sometimes they get kind of ugly, and sometimes you have to rationalize the denominator. Sorry, that's the way it is. Okay, not too bad though. Okay, let's do another one. Ooh, okay, getting a little tougher. Each time we're getting a little tougher. Okay. We're going to go with the point that goes through 9, comma, -3 root 2. So wait a minute, there's a couple things, we got some roots there, but I need to show you something else here. What happens when one of them's negative? Well, let's just find that point in the, there we go. Okay, let's find that point in the xy axis. Here we go. The coordinate system here. Okay. So the point is 9 -3/2. 9 in the, I'm sorry, not -3/2, -3 root 2. 9 in the x direction down this way, -3 root 2 would be down here. It's going to be in the 4th quadrant somewhere, right? This is going to be the point 9, -3 root 2, right? Because this is a negative, the y is negative, so it's in this quadrant. Okay, still, drop a perpendicular to the, or in this case, up to the x-axis, make a perpendicular, which creates a triangle. Now, this is going to be 9 in the x direction and -3 root 2 in the y direction. Same idea, only you call this negative. Now, you might say, hey, you can't make, it's a side of a triangle. A side of a triangle can't be negative. And I would say, you are right. This should be a positive thing. But I'm telling you, if you want to get high and mighty and not call it negative, that's fine. Then you're going to have to figure out every time you do it, where is it positive, where is it negative? I'm telling you, it's going to make it easier on you if you call this negative, even though I know you shouldn't call a side of a triangle negative. If you do, if it's in the negative direction like this, you should call it negative, and everything works out nice, because that makes the sine or cosine or whatever positive when it needs to be, or negative when it needs to be. You'll see when I do these calculations over here. Okay, so here we go. This will be theta now. Okay, so let's figure out the r. The r is going to be x squared plus y squared is r squared. So x squared is 9 squared plus y squared is -3 root 2 squared is r squared. That's 81 plus, okay, how do I square 3 root 2? Watch. Negative squared is positive, okay, so we don't have to worry about that. 3 squared is 9. Square root 2 squared is 2, so 9 times 2 is 18. It's 81 plus 18 is r squared. This is going to be 99 is r squared. So r is going to be square root 99. But wait a minute, square root 99 can actually simplify. It can be square root 9 times square root 11, which is 3 root 11. So I'm going to call the hypotenuse 3 root 11. Okay. So now we've got those distances. Now we just have to do the sine, cosine, and tangent, all that stuff. I'm going to give me a little bit of extra space here by erasing this part. That'll give me some more space to actually do some simplifying and stuff. Okay, so sine is, oh wait, let's write down what x and y and r are. x is 9, y is negative 3 root 2. R is always positive. X or y can be positive or negative. R is always positive. Okay, so sine is y over r. So it's going to be negative 3 root 2 over 3 root 11. Well, wait a minute. First of all, the root 11 is not okay. So we have to multiply by root 11 over root 11. But look, the 3's can actually cancel. So look what we get now. Negative, right? The 3's canceled. So root 2 times root 11 is root 22 over root 11 times root 11 is 11. But you can't cancel the 22 and the 11 because this is under a root and this is not under a root. So this is the, oops, the negative's out front there. Don't want to, I almost eliminated that negative. We don't want that. Negative root 22 over 11. Okay. Then, how about cosine? It's x over r. So it's going to be 9 over 3 root 11. Well, we don't want a root 11 there, so we multiply by root 11 over root 11. We get 9 root 11 over 3 times 11, right? 11, root 11 times root 11 is 11, times 3 is 33. Okay, they both have a 3 that I can simplify. I can make this 3, I can make this 11, and it becomes square root 11 over regular 11 positive. Right? There's no negative there. And then tangent is y over x, which is negative 3 root 2 over 9. Again, the 3 and the 9, they get canceled. That's going to be negative root 2 over 3, right? Because I just divided the 3 out of each of those. And then the others are the reciprocals of those. So cosecant would be r over, let's see, cosecant is reciprocal of sine. So it's r over y. So it's going to be 3 root 11 over y, which is negative 3 root 2. Again, I'm going to have to multiply by root 2 over root 2. It's going to get, and the 3's cancel. So I'm going to get, first of all, there's a negative. And then it's going to be 3, the 3 canceled. So root 11 times root 2 is root 22 over root 2 times root 2 is 2. The 3 already canceled there, so it's going to be just 2. So it's negative root 22 over 2. Okay, these guys are going to be r over x. So let's see. R is 3 root 11. Over x, which is 9. They cancel the 3's and you get square root 11 over 3. And then finally, cotangent is x over y. So it's going to be 9 over negative 3 root 2. We don't want the root 2 in the bottom, so we multiply by that. We get negative 9 root 2 over root 2 times root 2 is 2, times negative 3 is negative 6. Actually, I accounted for the negatives both times there. This negative is actually not there. There's only one negative total. That'll be, take a 3 out and I get 3, take a 3 out and I get 2, and it becomes negative 3 root 2 over 2. A little bit ugly with all the simplifying of radicals and things like that, but that's how it works. Okay. All right, let's do one more type of problem. I'm going to show you how to do one more type. Okay, find cosine if sine of theta is 1/3. Okay, so here's the deal. I'm not finding all 6 trig functions anymore. I'm finding just one type of trig function. Okay, I'm given the other one. I'm drawing a triangle, and I'm going to figure. Let me just show you. I'm trying to explain it. Let me show you. Okay, so find the cosine if sine of theta is 1/3. Okay, so here's my triangle. Right. Here's my theta. I don't even have to have it written in the XY axis, right? I could just write a right triangle here with an angle theta. There's opposite, there's adjacent, there's hypotenuse, okay? The sine is 1/3. Remember what sine is. Y over R is 1/3. So Y is 1, R is 3. Look, Y is 1, R is 3. Now the question is, well, what is X? We don't know what X is. So I can use X squared plus Y squared is R squared, which is going to give me X squared, that's what we don't know, plus Y squared, which is 1 squared, equals R squared, 3 squared. The hypotenuse always goes on the other side. X squared plus 1 is 9, minus 1 from both sides. X squared is 8. So X must be square root 8, which is 2 root 2 actually. So X is 2 root 2. Okay. So I just calculate the other side. Now, it says find cosine. Cosine of theta is X over R. So now look, I've got X, so it's just 2 root 2 over 3. And it's that easy. Boom. You just find the other side, then find what they're having you calculate. Okay. How about this one? Find sine if secant is 11/8. So here we go. I'm going to draw a new triangle. Secant, well, let me just draw the triangle. Here's my triangle. Okay, secant is 11/8. Secant is R over, secant is X, right? Because it's the reciprocal of cosine. It's R over X. So it's going to be 11/8. So R is 11. X is 8. The question is, what is Y? Okay, what's Y going to be? Well, X squared plus Y squared is R squared. So we're going to get 8 squared plus Y squared, that's what we don't know, is 11 squared. So 64 plus Y squared is 121 minus 64. Y squared is 11 take away 4, 7. 11 takes 57. So Y must be square root 57. Okay, and the question is find sine. Okay, sine. So sine of theta is, it's going to be, sine is Y over R, so it's going to be root 57, right? We just found that to be Y. Root 57 over 11. So there you go. So the sine would be root 57 over 11. All right. So that is, I'm going to give you guys a worksheet that basically are just like the problems I just showed you. You need to know all that stuff about what sine is Y over R and cosine X over R, all that stuff. That's what you're going to need to know. So this is the last assignment. So sorry to see you guys go. Sorry we were held up as far as not being able to meet together during the last part of the semester. I know that this is not the best way to learn material, but hey, it's the best we can do right now. So enjoy. Remember, all things all assignments are due by May 30th. I don't accept anything after May 30th. So after May 30th, you can't receive credit for anything. Let me show you what the assignment is here. It's just going to be a worksheet, but it's called right there, Intro to Trig Functions Worksheet. That's homework number 51. That one, as well as all other assignments that you're doing, are due by May 30th. So anyways, have a good summer. Hopefully we'll open up again in August, and I'll see you guys then.